My name is Trobradovic. I'm FLM at SDT Ultrasound Solutions, and I'll be talking to you today about ultrasound in marine applications. So when we talk about ultrasound in marine applications, we have to first understand, of course, the business model in shipping. So ship owners all have a business model in mind, but that ultimately should allow them to make money or profit. Making money and profit is not done with just sailing from point A to point B, but with trading cargo or passengers. So it is not only necessary to arrive in point B and discharge, actually a discharge port, but also to deliver the cargo there in time and in good condition, of course, without accidents and causing any havoc to environment. So this venture doesn't only depend on a good main engine and auxiliary engines alone, but also ensuring that the money makers or equipment that takes care of the cargo during the passage are all in perfect order. So main and auxiliary equipment, or rotating equipment usually, and critical equipment, or equipment that in case of failure puts the ship and crew in danger or causes damage to environment, is generally maintained under a planned maintenance system that is often based on support or supported by condition monitoring technologies like vibration, temperature monitoring, lube oil analysis, and such. Money makers are very often considered as a secondary equipment, so cargo piping valves, cranes, cargo, deep well pumps, heaters, coolers, winches, hatch covers, steam coils, reefer system, ventilators, and others. Now, limiting condition monitoring to the critical equipment alone is done because this is already expensive venture enough, complicated, often requires specialists and other reasons. Ultrasound can be, in this case, a game changer because it allows you to take care of your money-making equipment and to ensure that it is reliable and available at all times in an easy, simple, and most important, low-cost manner. Now, in marine sector, of course, we have different players and they are using ultrasound already. Like those we are mentioning. The shipping industry is a multifaceted business which includes shipyards, ship owners and managers, equipment manufacturers, shippers, charterers, surveyors, as well as a really wide variety of ship types which have all different money makers depending on what they do. So ultrasound can be used on different types of ships and for different types of applications, such as this one you see on the screen. RORO ramps, hatch covers, ventilators, quick closing valves, engines, life-saving equipment, of course, cable transits, piping and valves, watertight doors and windows, electrical motors, switchboards, steam systems, winches, box coolers. There's a huge variety of applications on every vessel. Now, how to connect the SDT and the quality ships? Of course, we have various ships performing various activities, and they all have various money makers. But they all benefit from ultrasound testing being implemented on board. If your ship crew and customer, of course, matter, if you go for a quality ship that delivers profit, embark on your ultrasound voyage yet today. And this is what we are talking about today. So just a little introduction to ultrasound. Ultrasound is coming from the three different sources: friction, impact, and turbulence. All three generate ultrasound. When we say generate ultrasound, that practically means we can measure it, and if we can measure it, we can analyze it, and we can use it for condition monitoring. So always think about assets that produce friction, impact, or turbulence during normal or abnormal operation. That means they can be monitored with ultrasound. Applications of ultrasound in industry are really various. We call it 8 pillars. So that means lubrication, rotating assets, leaks, electrical applications, steam system, valves, hydraulics, tightness. It's a huge area where any ultrasound inspector can practically deliver benefit to the company. This is one example to start with from tug and offshore industry. Now, thinking about this, what is the important money maker? What is very important to create a profit? In this case, winches. So the problem with winches, like with any other asset, of course, is they fail. They sometimes fail. So failure is the problem we want to avoid. So from the point of ultrasound, let's ask some very simple questions. Does it rotate? Yes. It rotates at a low rotating speed. Tested with vibration, thermography, or lube analysis? Usually no. If yes, it's quite ineffective. But on the other side, is it an important asset? Yes, it's a critically important asset. And we can certainly answer a question, can it be tested with ultrasound, with a firm yes. It can be done with ultrasound quite easily. Another one, moneymaker in this case, is the cranes. So the problem here is the failure of the sheaves most often. So again, the same questions. Does it rotate? Yes, it rotates slowly. The same situation with being tested with vibration thermography or lube oil analysis, not effective enough. Is it important? Absolutely yes. And again, firm yes question to the answer to the question, can it be tested with ultrasound? Of course. Now, when we think about three sources that we mentioned, three origins of ultrasound: fit, friction, impact, and turbulence. Let's start with the first one, friction. The friction is used as a primary source of information for condition-based lubrication. I hope everybody is familiar with a condition-based lubrication as opposed to time-based lubrication or any anarchy approach to lubrication. So we can group all the failures in the three common causes of bearing failures: over lubrication, under lubrication, and inadequate lubricant. There are a lot of subtle differences within, but let's just keep with the three main groups. So over lubrication, under lubrication, and inadequate lubricant will shorten the life of the asset. And according to the Murphy law, the asset will fail when you need it the most, of course. And all the failures of such kind of assets are extremely expensive. Now, mostly, still today, it's changing rapidly, but still today, time-based lubrication is out there. Now, is time-based lubrication a proper solution for this problem? Well, not really. Not really, because we have to understand that we often see recommendations like this. They say you need to lubricate every 3,068 operating hours, and you need to put 32.7 grams of grease, which is quite interesting to think about, because it suggests that somebody can be so precise to tell you 3,068 hours, not 7, not 9, of course. Of course, we have another problem here. We are talking about shaft with two bearings, drive end and non-drive end, which have a different load. So they require different lubrication regime. But usually it's recommended to lubricate them the same. So what I see here is very often is assumption based on estimate. Assumption based on estimate often comes from formulas like this one. Well, just to be clear, I have nothing against the formula. I'm a mathematician by my original education, and I believe in formula, but I really don't believe in input data. Garbage in, garbage out. If we have a problem with input data, of course the result will be quite problematic. We talk about temperature, we talk about contamination, moisture, vibration. All of those parameters continuously change. And even if you ask the asset operator, who is operating the asset every single day, knows his soul completely, you can ask him, what is the humidity today around this asset? You will not get a proper answer. If you need an answer, what is the contamination in this asset? You will not get a proper answer. So how to calculate with inadequate input data? And then again, we have output like this that is telling us that we need to lubricate every 3,068 hours. It's quite interesting how somebody is brave enough to do that. But then again, we have another problem. When the lubrication process is done, everything ends up with a check mark. Check mark doesn't prove absolutely anything. It doesn't prove that even job was done at all. It doesn't prove that it was done based on a schedule. And it certainly doesn't prove that bearing is now in a better condition, which is the ultimate goal of all of us who are lubricating bearings. So there are three fundamental questions that we need to ask every time we approach the asset with a grease gun, knowing that grease gun is called a gun for a reason, because it's dangerous. It can kill bearings. So we need to ask three questions every time we approach the bearing. First of all, it's really fundamental. Does bearing need grease or not? Just because the list or schedule or calendar says so, it doesn't mean that the bearing really needs grease. Maybe it needed it 2 weeks ago and we are already late, and maybe it doesn't need the grease at all. The second question is how much? Well, that's quite tricky because the real needs of the bearings rarely correspond with that what time-based schedule says. And the critically important question that almost always remains unanswered is it better now? So think of having a operation on a patient, and you finish the operation and nobody even asks, how's the patient? Did he survive? Well, we need to have this information because this is a unique job in industry that nobody knows if it needs to be done, nobody knows how, and nobody knows the outcome. And people are still doing it. So we need to know the outcome. Of course, this is the matter of completely deeper and other training, but let's go for the basics at least at this occasion. You can use ultrasound to prevent lubricant starvation. So just to illustrate how does it work to get you a feel, it's this. So this is the moment when the grease hits the bearing and gets into the rotation. And this is immediate response of the bearing. So that means you have a live immediate response that you can use to actually steer your action for the next one. You need to prevent over lubrication, of course. Over lubrication will increase friction, and on this graph you can clearly see that by adding grease we are making it worse. And if you have a proper equipment that will tell you stop it right now because it's going in a good direction, the problem wouldn't happen at all. Very often we have a situation with contamination when we have this intermittent, completely random, high-frequency, short impacts. It's a good information to know because something needs to be done. But if we don't know, we will probably not do anything. Detect bearing defect because there is a very specific behavior of the bearing during the lubrication if there is a defect in place. Like this one, not really a pleasant one. Or this one that doesn't have a sound at all. So you can see the graph is completely flat. So it's an interesting question. If I add grease and absolutely nothing happens with my bearing, it's quite a suspicious situation. That tells me that grease doesn't reach the bearing at all. So there might be a problem with a grease line or fitting issues and something needs to be done. Just to conclude this chapter very fast, this is a way to illustrate how technology helps. So intelligent system tells you what you need to do. So you need to put XYZ shots of grease and press enter to start analysis. By the way, I'm also giving you a sound file so you can hear how it sounds when you are there. Still, making decisions based on sound is not really a clever idea when you want to do a precision lubrication. While instruments are perfectly calibrated, at least SDT instruments, on the other side, our ears are not really calibrated, and that's far too subjective. The changes during the lubrication are very subtle sometimes, and we need to be extremely precise. So intelligent system that analyzes the signal on board during the lubrication live and giving you a proper recommendation what to do next, as this one, and this recommendation says, okay, you are done, finished. The task is completed, we reached the minimum friction, pack your things and move to the next bearing. The job has been completed with lubrication success outcome. So just to give you another interesting aspect how to combine condition monitoring and lubrication in the same task, because we all know the same problem. There is never enough of manpower, and there is no chance that we will have more manpower just because we think we should have. That doesn't happen. So what we need to do is to do more with less or same. That means that we need to make the person who is greasing the bearing not only to be greasing them to perfection, according to lubrication excellence best practices, but also to do some additional job without spending additional time, and that's condition monitoring. So the data you see on the screen was collected during the lubrication process. So first of all, you have a time waveform and spectrum before lubrication, quite messy, and then you have a time waveform and spectrum after lubrication. It's not always like this, not necessarily. In this case, it was perfectly healthy bearing that needed grease. The situation can be completely opposite. It can be a bearing that needs grease, but it's defected. And that's a highly valuable information for condition monitoring team. And that information should be collected during the lubrication process. And this is what happened actually. So you see this beautiful response of the bearing and the data that follows the entire process, telling you your KPI, what is the outcome, and telling you what is the value before and after lubrication, as found and after the process. So condition-based lubrication has lubrication excellence in general has a huge place and a critically important place in marine industry. And we can just mention one example of winch, high and low speed. If there is an improper functioning, anomaly, or failure, there is a huge problem with delays in coming alongside, breakaway incidents, accidents, and that all costs a lot of money. Now, implementing optimal greasing and lubrication program or entire practice for rotating machinery can be done on generators, bow and stern thruster, steering gear pump, ballast pump, engine room fan. Everything that needs to be lubricated should be lubricated properly. Now, when we talk about a second source of ultrasound, impacts, we can connect it with condition monitoring. Implementing of condition monitoring for rotating machines and not exclusively for rotating machines have some considerations that maybe it's interesting to mention them. Surrounding noise is not a problem because ultrasound works in a much higher area. Whatever we as humans consider as a noise or noisy environment, it's not necessarily a noisy environment. Usually it's a very nice, peaceful and quiet area from the ultrasound point of view. So that means it's quite easy to use ultrasound in this environment. The measurement and trending is quite easy and quite simple. Learning curve of the operators and inspectors, it's very steep. So that means that immediately after the training or at least starting instructions, operator and inspector can start delivering benefit and delivering profit. Within months, he can be on an extremely high level and have a very good understanding what needs to be done. You will see in the following examples. Data is being recorded, of course. It's not about listen only. Not that I have a problem with people who are taking the screwdriver and listen. That's quite nice, but the data needs to be recorded because that data needs to be trended and analyzed for understanding what might be the problem. And on top of all that, just like in any intelligent condition monitoring system, it's very wrong to think that one technology can solve everything. It's completely wrong. We need to combine several technologies. So when you're working with a proper ultrasound instrument, it will give you an option to work with vibration, ultrasound, and temperature simultaneously, like the one you see on the screen my dear friend Patrice using. Routes, alarms, analysis. This is how the job is done. So create the routes, create a typical work task that needs to be optimized according to the availability of the crew. Then we need to set up certain alarms to have a nicer approach, to have a primary filter that will tell us green, 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 and this is red. Now let's focus on red. It helps a lot with optimizing the task, and of course then analysis. I will go through several examples right now. It might be quite noisy, but that's where the information is coming from. This is from testing generating on a cruise vessel. It has been showing a typical spectrum of mechanical looseness associated with incorrect tightening of the bearing and the shaft of an excessive clearance. Now, look at the graph and take a listen. Even without any deeper training, you can see that graph doesn't sound very regular, doesn't look very regular, and the sound is definitely suggesting strong impacting. That's the first step, really, and that's the first step in how intuitive it can get, that you can definitely see that there is a problem. Now, to be sure there is a problem, let's listen to another one. Another one sounds completely different. And there are we cannot see those repetitive impacts. So at this point, we can answer the first question: is there a problem? Yes. So where is the problem? It's not on a generator 2, it's on a generator 1, on the driven end. So let's look a little bit deeper. Let's analyze the time waveform. Let's try to understand what is exactly the problem. That's our next step and our duty. And from time waveform, we can understand what is going on inside and what is the problem. And also from the spectrum, we can clearly see where the problem might be coming from. The next example is, as I mentioned, the steep learning curve. In this case, the crew was trained to take the measurements. So for 2 months, as you can see in this graph, everything was going nice and easy until somewhere at the end of the August, crew saw an increase in measurement indicating the problems. But not only that, first of all, you can see the numbers are going up quite rapidly in recent days. Graph shows definitely that everything is going up. And when you listen to the signal, this one coming from the end of June, and then we have something in end of August. And it's quite self-explanatory. Now the next step is to look at the time waveform, look at the spectrum, and understand to pinpoint where the problem is coming from exactly. Now, in this case, emerge of peaks on the bearing number 9 spectrum, which is not the case with all the others on the shaft line. You can hear that one. Now, following the shaft and testing all other bearings, this was the result on other bearings. So the primary task of condition monitoring, to take the route or work order or work task, monitor all the bearing and make the first screening, a triage. Here we can definitely exclude other bearings and focus on that one, and then expert or anyone of the crew who is trained on a slightly higher level can look at the time waveform and spectrum and see what the problem is. On the RORO vessel ballast pump, this is ballast pump 1, bearing drive end, and this is number 2, same position, bearing drive end. So you can see indicators. We are using 4 condition indicators: RMS max, RMS peak, and crest factor, and each of them has is containing a certain very important information for trending and alarming. In this case, you can see there is a dramatic difference between these two, and of course the alarm has been triggered, and now we need to look deeper and understand what is the problem. On TUGS bearing starboard, you can see at 1000 RPM, the vibration was about 30 millimeters per second, and the bearing 1 at 1000 RPM, there was no sign of problems. But at 1600 RPM, when more load was applied, the problem was quite visible. Again, next step, look deeper and try to understand what is the problem. In this case, we understood that there is the signature in the spectrum which is synonymous of the structural resonance. So the problem was found, problem was defined, and now is the task of the maintenance crew to say what do we need to do next. When we talk about this part, offshore sites, windmill installation, in this particular case, boom tip vibration was high, and we all know that this application, the cost per day is huge, it's enormous, and the crane in this case is the money-making part. Sheaves are only a small part of that crane, of course, and it's quite impossible to access it when in operation. So understanding that renewing sheaves and wire takes at least 1 week, we can understand that we are talking about a very expensive problem. So the solution to this problem was put ultrasound on sheaves to monitor them. Considering difficult access, it should be permanently mounted and then measured from the safe position, or include online condition monitoring, which would be absolutely the best solution. In this particular case, it's quite easy to understand that there is a problem, especially for somebody who is beginning, if there is a signal, how it looks like when there is no problem. Now, every time a team wants to implement ultrasound, there must be a strategy definition. Strategy needs to be defined in a way that serves you, brings benefit, and it is within your capability. So several things to consider is definitely your ship and its needs, core tasks and equipment, secondary tasks and equipment. Make a deep review of your PMs to understand what is being done, what can be optimized. Is there a more room that we can do, or can we eliminate some of the tasks by combining them with ultrasound condition monitoring? We need to consider OEM requirements. We need to implement condition-based maintenance. So that means that the condition monitoring team should have a say when something needs to be changed, maybe on a time schedule. So there cannot be a mixture between two of those, because that always leads to a disaster. The question that was always asked, if time schedule says we need to change a bearing, and the condition monitoring team says no, everything is working perfectly, who wins? And that's the matter of strategy. The strategy needs to be implemented, the rules needs to be clearly defined. Also consider insurance as well, quite important part. Now, implementation of your ultrasound strategy on board, the implementation program is not buying the technology. Buying the technology is only first step, necessary, but only first step, because instruments themselves don't do a strategy. They are actually offering you data for you to develop your strategy. Several advices: think big and start small. See your final destination. Understand where you want to go. Understand what you want to achieve. Start small. Start from several items, several assets. Give your team a chance to warm up a little bit. One of the biggest mistakes I always see in implementation is that people are hungry for a huge success. And then they have a troublemaker asset in a company that is several $1 million asset, and they finally get some technology and they put all this pressure on the team saying, okay, I purchased you your toy, now deliver me something. Here is the machine, do something about it. That's very inappropriate approach. Now we need to give some warm-up time to our team, to get some experience, to get organized a little bit. Also, don't forget that within the team there will always be some talents arising, and then you will reselect your team and people who will do the ultrasound and how. And also issuing a soft license to fail, as I like to call it. So be reasonable. You're implementing the strategy. Buy the right material for your ship and strategy, of course. Know your ship and crew. Know your ship as an asset. Know your crew as an asset. Because each and every one in that crew has a certain talent, certain knowledge, certain aspirations, certain wishes, and certain capabilities. So managing assets and people is equally important. Preparatory work in the office, absolutely. So there is a very intelligent and high quality software that will allow you to prepare a huge portion of the work within the office, nice and easy, without pressure, and then to understand what needs to be done when you go out in the field. Share responsibilities to different people for different applications and different tasks. Of course, involve juniors. One of the things we see very often is that we have a fantastic condition monitoring teams. Juniors are not involved. The old guys go away and knowledge goes away with them. That's wrong, because knowledge comes from the training and experience. Younger guys are learning from the older colleagues. So involve juniors immediately in your ultrasound strategy. You might be surprised, by the way. Selling your plan on board. That's very important, because people like to have their own projects. There is always a question that is floating around and nobody likes to answer it actually, is what's in it for me? So yes, the company wants to implement this strategy. Oh, nice and beautiful. So do we get more people? No. Okay, again, the same thing. So the question that is there, okay, what's in it for me? Why do I need to put so much effort, and what will be the outcome? The higher profit of the company is not the only outcome. Better planning, less maintenance, more knowledge given to the crew, more expertise, a possibility for promotion, going up. All this stuff needs to be included in selling your plan aboard. You need to sell it to everyone, not just to some. And of course, onboard training, critically important. Without training, all the instruments are just a box full of electronics. Training is critically important because the strategy needs to be implemented by people. When we talk about trainings, of course, I can always recommend, at least from our side, level 1 and level 2, ISO Cat 1 ultrasound certification, ISO Cat 1, 2 and 3 vibration certification, Sherlock hatch cover testing ultrasound certification, critically important, partnered ultrasound as a way to help our users, partnering with them and following them on this journey. SDT training, where you can do most of these things online, and of course LubExpert training, specialized training for the application of lubrication. What I can say after this is have a proper technology in your hands, understand applications you want to do, and then get trained so you can deliver the benefit. Thank you for your time. I hope it was useful presentation, and now it's a question time. Thank you.